Yes, but I will tell you when it's all good. It's just on Zoom on the side.
All right, no worries. Yeah, gotta get everyone pumped up.
Okay, so let's wait 3 minutes for starting. All good. I don't know why it's putting like error generating preview. So just wait. I think it's because of Twitter right now, who it's working. With OBS, I think they cut the access because like looks like I can't put any stream key or whatever. Um,
Hmm, it's weird. You're using Riverside or no?
using what? Sorry.
What are you using Riverside or are you just doing it directly from your software or how are you doing it?
With OBS Studio.
Oh, with
OB.
OBS. Okay.
Yes. And so actually, yes, it's like I can't access the sitting side with Twitter, so that's pretty weird. But all right. Otherwise, we'll put the recording on X, like with YouTube link anyway. Um, but sad. Very, very sad.
Yeah, that's unfortunate. Maybe if you tried to, well, no, because you have to use the streaming key. What if you tried to go generate a new streaming key?
I
That
can
might
do
work.
it. I can do it.
Uh,
That's why. Yeah.
yeah,
I
that might
want you
work.
to modify that. But yeah, I can do it. So All right. Tuk. Anyway, we can't change that. Thanks X. My God, they
Yeah.
have done a lot of shit, literally. But all right, that's fine. We will do a good X tweet about it after, and that's it. Let's see. Let's see. Okay. Anyway, all right. So sorry. The stage is for you. So I actually, for those who are there, so the goal today is more to talk about x402 protocol, which is something I very use from now, especially not only just in Web3 but in general. And so it's great to deep dive into it, because during this month, we will have a couple of sessions more on the agentic AI stack. And so for that, X402 is well used. So just we will have some insights from Kevin today about what's this, but also like use cases behind it, and with some mini workshop, like how to build with x402. So yeah, don't hesitate to ask any question. It's really like beginner friendly. So yeah, just to let you know. And yeah.
Awesome. Cool. Thank you so much, Celine. As always, really pleasure being here. And thank you so much for having me. So, hello, everybody. My name is Kevin Jones. I am a developer relations engineer working at Agenode. So, I work for one of the main companies that created the Graph protocol. I'm also the founder of a application called Spritz, which I'll talk about a little bit about later, and also Genesis, which is a developer community. I see some familiar faces in the crowd, so thanks so much. So we're going to be focusing today about talking about x402, like kind of what it is, how it came about, and then also more specifically, we're going to dive into like some use cases of how you could build on it. One will be kind of like a hands-on workshop, and then a real quick implementation of how we actually integrated this stuff into Spritz. So without further ado, let's dive right into it. So let me go ahead and share my screen and close this up. And make sure we're on do not disturb. So no one bothers me. Okay, cool. All right. So x402 is interesting because it's one of these actually HTTP status codes that's actually been around for like a long time, right? X402 is a re-implementation, not a re-implementation, but it's kind of like a protocol that's been like wrapped around this existing error code that has actually been sitting there for a while. It's actually funny. If you go to MDN, you'll actually see here that says the status code is reserved for future use. So like someone was actually really like thinking, beyond back when they started creating these status codes back in probably the 90s. I don't know exactly when it was, but it was a long time ago. And the idea was that they knew there was going to be a way where you had to monetize HTTP resources. And so it's a little bit of a interesting thing. And recently, well, I shouldn't say recently, we have seen a surge in agentic commerce, right? Or like concepts of where agents maybe could do commerce, right? And we're seeing the rise of AI agents in general trying to operate autonomously. And so Gartner actually estimates that by 2030 that there'll be $30 trillion in purchases made via AI agents, right? So X402 is actually a perfect fit for this kind of use case because it allows an agent to have its own private key and essentially sign transactions or, yeah, basically make purchases over this HTTP 402 protocol and get access to information that it otherwise would not have access to. Like everything in payment systems today is very much like you need to swipe your card and put in your little PIN code, or you need to put in your zip code. And there's a lot of like human interactions that happen, and there's not a lot of systems that are built for something like an AI agent. So again, x402 came out of this kind of idea that crypto native payments could be a solution to trying to get access to, and not just for agents, we'll go into some other examples, but it is the most common use case right now because an agent might need to get access to some data, or it might need to call an API. And previously, like you were working with like API keys. And another promising thing about x402 is it goes to try to replace the API key, right? Instead of charging and doing this kind of like tallying of requests via like an API key, we can just do that finalization right away using x402. So x402 is very like simple in terms of like implementation. It doesn't take a lot to kind of add x402 to an existing endpoint. As you can see with like this little snippet, it's really just like a couple lines of code. And this will basically allow you to start accepting payments for what would normally be like an API key that you would have to give. So there's a bunch of different layers to x402. We'll kind of go over these real quickly, and then we'll kind of dive into a little bit more of like the white paper and like how it works. But generally speaking, the idea is that you have buyers and you have sellers, right, that want to get access to or make HTTP requests over HTTP. And this could be like a client paying for access to content, like data, like something like on the graph, or it could be paying for access to call an API to make some kind of like update on something. Anything that you could do over an API could be turned into an x402 payment. And then there's a couple different specs that have risen out of this. There's HTTP v1, and then there's also v2. So that's important to understand. There are some slight differences. And you can provide x402 access for different like means of data. So you could have a HTTP asset that again is like an API that you want to give access to, and you want to require payments for that. You also could have an MCP server that is running all of your APIs. So it's one single MCP that kind of like manages access. If anyone doesn't know what an MCP is, it's a model context protocol. It's like a way for agents to get access to data in a more consumable way versus something like an API, which can be varying. MCP is a very specific protocol. And then also Google A2A, or agent to agent. And this is the idea that, well, in the future, agents will be talking to each other. So we'll actually do a workshop on A2A today, and we'll show how that works. But in the future, like one agent will need to pay another agent, right? It's not necessarily an agent talking to a server. It's an agent talking to an agent, and then that agent maybe is talking to a server, right? So there will be multiple layers of access for data in the agentic future. And this is kind of that additional kind of thing. And I think that's the future. And then there are different schemes. So like the most common scheme is the exact scheme. And that's like, if you go to the store and you want to buy some candy, the candy costs, 5 cents back in the 50s. Now it's probably more like $5. You give the $5 and you get your candy. Something like a deferred scheme, which is something that is Edge and Node has been working on, is a idea that maybe you could like not necessarily settle the payment. So it's a way to do like credit on the blockchain by providing some kind of mechanism to defer payments. So maybe you have like a candy shop that you go in every morning on your way to work, and you always buy a candy bar. So maybe you don't need to like pay him every time. You just kind of take the candy, and then at the end of the month, you tally that up. This is that like deferred scheme. So there are these different schemes you can use inside of x402. And then we also have like different chains. Like x402 can be on any chain. So the most commonly obviously is going to be Ethereum, because that's where the creators of it, which is Base, have probably the most traction. Solana is actually very popular as well. And then you can move like any asset. Like a lot of people think like, oh, x402 is only for stable coins. That's not the case. You can move any kind of asset across x402. So it's very generalized. The spec is very open. And you can also like set the terms of like how you want to like do that, how you want to like exchange, like what's the way the person needs to settle, right? And this is like EAP 3009, which is like Ethereum signatures versus, you know, Solana fee pays, or permit to, which I'm not sure what permit to is. I guess it's just a different, maybe it's something with AVAX, I'm not sure. But anyways, this is kind of the layers of 402 if you think of it from a protocol spec, like kind of laid out. This is how an x402 transaction actually looks. So you can imagine me, I'm an AI agent, and I want to get access to, let's just say I want to get access to the current swaps on Uniswap. Like I want to know exactly what swaps had the most volume in the last 5 minutes, right? So I would like say, oh, I want to get access to that data. I would make an HTTP request to an x402 enabled server, right? That is probably running something like the subgraph MCP server that has access to that data. And it would reply and say, I can get you that data, but I need to pay to get it, right? So it would give me a 402, and it would say exactly what I needed to do in the response header of like where I need to go, what chain I need to make the payment on, what asset, how I need to settle, like all the spec stuff that we talked about here is embedded in the response to say, hey, all right, well, you need to go and make this payment. And then when you do, you need to like sign off the payment and send it to me in an additional header, this X payment header. So then I say, sure, no problem. I sign that, and then I send it again. When I send it again, it takes my signature and all of the embedded data inside of that header, and it forwards it off to what's called a facilitator. And the facilitator's job is just to verify that everything is good and do the transaction and make sure that it's going to be able to be settled, right? On the blockchain, right? If I don't have a balance, obviously it's not going to let me do that, right? So it's going to verify and check everything. Then it's going to go out and do the actual settlement of the transaction again, and then it's going to come back to the server that originally said, "Hey, you need to pay for this," with a header that says, "Yep, he paid, and it's confirmed, it's been settled," and then that server is going to give me the data that I need, right? So it's very, very simple. It's similar to it is HTTP essentially. And we're just basically allowing access to that information based off this kind of x402 payment. There's a lot of tools to make it easy to build on AI right now. There's like thousands and thousands. Like AI, we're in such a golden era of like building. You can really just build anything very simply. I would advise you to try out like Ampersand SDK. This is just my first or my really quick 5-minute shill on it. It's basically an SDK that helps you build x402 powered apps. And we currently support Google A2A, and we also support, we have an MCP implementation that you can use fast MCP to build an MCP server. And then we also support HTTP. So it's a good all around kind of toolkit. It's very lightweight, and it's in Python and TypeScript. So you can kind of make your decision on how you want to build. We'll actually show this off today, just because it's pretty easy to use and stuff like that. So, oh, one more slide. Sorry, I missed this one. What is the Ampersand SDK? It's a implementation of Python for Google A2A, and it has embedded with it what's called the Agent Development Kit, which is Google's Agent Development Kit that lets you do agent-to-agent communications and testing. So it's this cool little kit. We also support MCP and HTTP over TypeScript. It has smart account integration. So what's cool is you can hook it up to smart accounts to do the more advanced signatures for smart accounts. And it works with the Ampersand UI to basically do like guardrails, which we'll talk about here in a sec. And it comes with all of the client and the server components. And it has this cool pattern called a treasurer pattern, which is basically like guardrails for like spending. Like you can imagine when you give an AI agent a private key, things can go wrong drastically, right? Because if it has too much money, it could spend it all on like an endless loop, and we'll show that in a little bit. Okay, So if you want to get more information about x402, what do you do? Well, the first thing is you should check out x402.org. There's a link to the white paper. I know not everybody likes to read white papers. This one's pretty good. It's got a lot of really good diagrams in it. Explains the protocol in very, 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 very detail. There's just kind of like some stats on their website. Yeah, some information about how to get started, facts. There's also a blog that they do. And so if you want to understand like x402 version 2, there's a good blog that just came out last December that is still very relevant. I don't know what ecosystem is. Oh, ecosystems like partners and people kind of working in the space, which is pretty cool. And yeah, so let's kind of dive into this. So I want to start by doing a demo, and the demo that I'm going to do is using ampersand SDK, and it's going to be using a couple different things. It is let me go into here real quick. The architecture for this demo is this. What we're going to show off is an agent to agent use case. And more specifically, we're going to have one agent that's a buyer. So the typical flow for like an x402 is you have a buyer, right? And you have a seller. And it's a good chance that both of them could be x402 enabled. And that means that the seller wants to get paid in crypto and the buyer has the ability to make crypto payments, right? We're talking about agents here, right? Buyer and seller. In this scenario, we're going to use Google A2A, which is the agent-to-agent framework, right, by Google. We're going to use x402 to make payments. And the data that the seller has access to is actually an LLM query. So what's cool about this, I don't know if you guys have been following all the stuff with like OpenClaw and like, we have like a lot of the different like services that you can get for like LLM inference. Like you can just go directly to like Google Gemini, or you can go to, whatever, Claude, or you can use something Open Router, which is really useful because you can like kind of get the best price and like kind of have this like additional value and like finding other models. It's easier to configure. Block Run's pretty cool because it allows you to pay for your inference with x402. So we're going to have our agent that is a seller that's selling access to the LLM to Block Run. So normally you might need an API key for something like that, but we're going to completely not need the API key because we're going to use x402. So we're going to have the buyer, the seller making communications over x402, and then the seller and Block Run will also do x402 settlements as well. So in this scenario, the seller is accepting x402 payments and the Block Run API is also accepting 402 payments. So the buyer will try to get access to the seller. The seller will say, well, if you want access to this LLM, you need to pay. The buyer will pay. Then the seller will say, well, I need to go out to the Block Run and actually run the LLM inference, but I also need to pay. So it will make a payment and it will pay. So there'll be two payments, and then we'll get all that come back to our user here, which is the buyer, who just cares about figuring out what the answer is, okay? This code is not live yet, but it will be live soon. This is actually like the very first time we've publicly done this demo. So it should be out probably by the end of next week. And I'll make sure that we get that shared with you guys. So again, we already talked about what the single request looks like. I think we know that. Let's just talk a little bit about what it looks like in actual code. So generally speaking, when you're using something like an SDK, we try to abstract as much as possible. So in these scenarios, we're not actually looking at the x402 code. We're looking at this very, very high level configuration of how the SDK needs to be configured. And in this case, most of the time we're dealing in two things. I hate when that does that. Hold on, sorry. We're dealing with a smart account address, which is a public key for a smart account. If you don't know what a smart account is basically a smart contract wallet. So you might have an externally owned account on your phone or on your laptop, on your browser. A smart account is a smart contract wallet. And what it allows you to do is it allows you to like send payments from it with some kind of additional logic, which is very useful. So when we create a buyer for basically buying the LLM inference, we need to pass in the public address, the private key, which is the how we sign the transactions, and then the API URL for ampersand. So the reason why we're doing this, and I just want to mention this because it's a little confusing at first, is the cool thing about ampersand is it allows you to require that something has to come back from the API before it actually makes the payment and signs the payment using the private key. So this is kind of like the most powerful thing about this demo is in order for the agent to sign and make a payment, it needs to go to ampersand and make sure that it has the ability to do it within its rules. So it allows you to set up rules for your agent's payments, okay? That's pretty much the TLDR. And then here we have the BlockRun API client. So this is where BlockRun itself is configured. So in this case, we have the base URL for the LLM. And you can notice here that API key is x402. And that's saying that there is no API key. We're not using API keys. We're only using x402, which is really cool. And then this last one is just like how we have our agent configured, which is like, hey, you're a useful AI agent. And then it has things like the price, like how much does it cost, what network that we want to accept our payments on, stuff like that. Okay, so let's try to run this demo real quick and I'll kind of show you what we're working with here. So we're going to first run, so again, it's an agent to agent demo. So we're going to run the seller first, okay? The seller is a Python application because it is Google A2A, right? So how Google A2A works is when you spin up an agent, that agent is listening on a specific port like this, and you get this agent card. It's kind of like if you're familiar with, well, it's like discoverability feature. So if you are trying to find an agent, you can kind of browse through all of the agent cards and you can find one that is matching what you're trying to get access to. So you can imagine in a world where you have like thousands of AI agents running inside of your infrastructure, it might get hard to find them. This is where like you'll learn this next week, I believe. You're going to learn about ERC 8004, which is like a registry and like stuff like that. But this is very specific to Google, okay? And this allows you to build a bunch of agents, run them in a cluster, and then allow them to find each other easily by like these cards. So we have our agent running on port 8001. It's up and it's ready to go. And this is the BlockRun agent. So this is the seller agent. This is the one that has access to the LLM. It has access to the testnet right here, which has access to the OpenAI GPT OSS 20 bytes, or I think that's 20 bytes. And it has a wallet address. And it has a base price. So this particular agent is charging a fraction of a cent, $0.002 to be able to run LLM inference, right? So then I can come down here and I can run a query against it, okay? So I can say, all right, same thing. We're going to run this Python app, which is also a Google A2A app, run this script or this Python script, which we can look at in a little bit. But in this case, I want to be the buyer and I want to send in an LLM prompt. And the question is, what is 2 plus 2? Pretty simple, right? So let's do it. Let's go ahead and ask. So at this point, I'm going to have two agents talking to each other using this inference. So here it goes. It's basically going out, it's finding the thing, and then it's going to come back with the answer, hopefully. Let's see. It's a little slow.
Kevin,
there we go. Yeah.
Just to let you know, I managed to fix the stuff for the live stream.
Oh.
So if you want to go live for the demo, feel free to let me know. You want to go live on X for the demo? Or
yeah, sure. That's fine. Yeah,
okay.
No problem.
So just 1 minute.
Okay.
and all good. If you want to
Okay.
restart, maybe
Yeah.
just
Yeah,
just
yeah, yeah. It'll be a good reviewer too. So I'll stop
yeah.
this agent for now. Yeah, that's a good idea because I think this is definitely still a little confusing. So yeah, I can kind of briefly, yeah. Let me know when you
Uh,
start.
yes, sure.
Mm, I can have some coffee.
Okay, so create broadcasts. X.
See if there's any questions while we're waiting. Oh yeah, someone calling out my Web3 privacy now. Woo. All right. Yeah, happy Friday the 13th. It's crazy. I always get scared on it. Like, what's gonna happen on Friday the 13th? I always like feel like something bad's gonna happen. Yeah, if you have questions, please let me know. So for the demo we're gonna do is gonna be on Base Apolia. So currently ampersand only is supported on Base Apolia. X402, will work on any chain. Um, the main thing is we're doing smart accounts on x402 on base. Or sorry, we're doing smart accounts on base. And we do some like auto top up stuff with the accounts. And so that's the current chain we support. We're going to be adding more soon.
Okay. So feel free to let me know when you will be ready. When you
Yeah,
are
go for it.
ready, I just switch to the sun. Let me just check on X if all good.
Mm-hmm. No problem.
Yes. Yes, all good on X. So I can just yes, what you want to start with, like with the demo, I guess. So here it's
Yeah,
all good.
sure.
Okay.
Yep.
So let's go. I will tell you when all good.
Okay.
One question, if I may ask quickly.
Mm-hmm.
Are we supposed to follow up, or you are just going to do it for us to see it?
Um, well, so this one's not public yet, but if you guys want to do this on your own, it's really up to you. We're going to release this publicly next week, I believe. And so once it's available, I'll give it to Celine, and then she can give it to you guys, or I'll put it in the Telegram chat. I know you guys have the Telegram chat. I can drop it there.
Great,
Yeah,
awesome, thank you.
all good.
Mhm.
We can start.
All right. Woo, here we go. X402, X402. You guys missed the first part, but we're going to dive right into the demo right now. Okay, cool. So we're going to be talking about specifically the ampersand and block run integration that we are going to be unveiling next week, and we're going to do this demo. So basically, the TLDR and the demo is, again, we have a buyer and we have a seller agent in an agent-to-agent architecture. So if anyone's not familiar with Google A2A, again, it is this agent to agent architecture where agents can talk to each other, pay for stuff using x402, and kind of operate autonomously, right? That's the dream goal, right? And so in this architecture of this demo, we'll have a buyer and a seller agent, and the seller specifically is selling access to Block Run AI. So Block Run AI, you guys have probably heard of, Open Router, or you've probably heard of, the individual providers like Gemini or Claude. Block Run is awesome because it allows you to pay for your LLM inference using x402. So in this scenario, we'll have a buyer talking to a seller. The seller will also need to pay for his data that he's getting from BlockRun. So the buyer pays the seller, then the seller pays BlockRun. So there's two different x402 transactions that happen and settle all of this with no API keys. That's like the most important thing to think about here. No API keys, all x402. So we talked briefly, I'll just mention it here. We have this idea of a single x402 transaction in one request. The buyer wants to get access to the LLM. The seller says, sure, you need to pay 0.002 cents or dollars, which is a fraction of a cent. The buyer signs and makes the payment via the x402 standard. The treasurer checks to make sure there's not a daily limit. So in this scenario, we're using ampersand, which ampersand is our management platform that allows you to control spending. So we're basically going to issue a private key that has it's kind of like giving a teenager a credit card. We only want to give them a small amount, right? We're going to give the buyer like a little tiny $100 tally or something. And so this treasurer pattern allows us to set these limits. And then the seller also needs to send the data to Blockrun to get the LLM inference completed, and it needs to make a payment. So same thing. And then the LLM response comes back, and then the seller gives the response to the buyer. So it's this proxy solution for agentic communications over x402. That's the beauty of x402 is it's all proxy level HTTP payments. Okay, so we have outbound payments. In this case, we have the seller paying Blockrun. So we have the same configuration kind of in both scenarios. When the buyer wants to when the buyer wants to get access to the LLM inference, it needs to pay the seller, and it has certain rules. Same thing goes for the seller. When the seller wants to pay Blockrun, it has these certain rules that need to be controlled via this API. So you can think of this as the credit limit, right? That the agent has. We pass the private key and the public key, and then we have the access to the OpenAI. And what's important here is there's no API key, right? We are using all x402. And then, then we have this like very last inbound, which is the buyer paying the seller. Same similar thing. The difference is that we are specifying what LLM that we care about, and we want to use, what network that we need to pay on, how much we need to pay, and the pay to address. So this is all stuff that's handled via the SDK, which is really, really useful, okay? And then this is what a treasurer looks like. I didn't talk about this earlier, but this is very useful. So again, the treasurer, you can think of it as like the gatekeeper for how the agent is allowed to sign his payments, right? With ampersand, we control that, right? Using this special API. And it has its credit card information, or not his credit card, it's private key information, just like a normal agent would. But instead, we make it pass through the treasurer right here. Okay. All right, so let's do it. So this is a Google A2A application. We're going to spin up the seller first. So Google A2A is primarily written in Python. So this is a Python application. We're going to pass the seller flag. So this agent is selling access to the Blockrun LLM. And what we're going to get here is the public address for the agent, what network it's on, what network it wants to get paid on. Let me move this real quick. Okay, what network it wants to get paid on. What the API is for the LLM, what LLM it wants to sell, basically, how much it costs to make queries, and the port. And then we get this well-known card, right? This is like the discoverability layer for Google A2A. And so it's up and running, okay? Now we're going to make one simple query. So we're going to do Python examples as a buyer, and we're going to send in what is 2 + 2, okay? Answer. So we should, at this point, what's happening is the buyer is saying, oh, I want to figure out what 2 + 2 is. It's talking to the seller. The seller says, you need to pay me. It is going to go back and create a signature for the request. It's going to resend it. Then the seller is going to say, cool, now I need to go to Blockrun. Blockrun is going to say, oh, I need a payment. It's going to send the payment. And all this is going to get verified on chain. And then all the data is going to come back from the LLM and come all the way to the client, which that's what happened right here. We got 2 + 2 = 4, okay? So it is working. We have this agent talking to this agent, and this agent is talking to Blockrun. And the important thing to note here is that we have no API keys, no API keys. This is all done using x402. So I want to just go up here and take a look and show right here. This is the payment stuff, which is super useful. So we have we have the scheme was exact. The chain was based Sepolia. the amount required was 2,000. I think in this case it's Gwei, or no, it's with the lowest denomination value, which is eight decimals, I believe, which is 0.002 cents or $2. And it has the resource that it needed to get access to, how much it needs, why it needs to make the payment, the type of data that's coming back, who the payment has to go to, what the asset is, and this is the specifics about the asset, what the token name or token is, the token symbol, and what version. And then here you can see where the validation happened. So this is where we actually verified that the payment was successful and it was true, and the payer was validated. So we validated that transaction, okay? And you can see that it happened twice. So we have the payment to the seller and we have the payment to the LLM. Okay, so there's two x402 transactions that happened here. Okay, so what we can show real quick is, let's just go to stage, so API, or sorry, staging.ampersand.ai. So we have two environments for ampersand. We have our production endpoint, and then we have staging. They're currently, you have to like request access for production. I think the stage is open. But if we come over here and look at our agents with activity, and we go to, I think it's Susie the seller and Zach the buyer. Yeah, it's these ones. So we can open up these. So I have two agents in this scenario. This is the seller that's selling access to the LLM, okay? And this is the buyer that is requesting access to the LLM. So we have these two kind of like things here. What I can do is I can control spending on these. So I can say like, oh, I want to control, and I only want him to spend a penny, okay? Just for the sake of demo. So he can only spend a penny. And the seller who's trying to access the LLM also can only spend a penny, okay? So this is the cool thing about ampersand, is you can have these keys and you can like control their spending. So I've created these control guardrails for the buyer and the seller. So now if I come over here and rerun my demo, but in this case, I'm gonna run a load test instead, which is a bunch of requests. I'm just gonna send the same thing over and over and over and over and over again and let it run. And what we're gonna get is a bunch of transactions that were successful, but then we're gonna just get failures because we're essentially using ampersand to control with that treasure pattern, right? So here we go. We got like some settlements happening, and there we go. So we were able to do two transactions, but then the rest failed because of the spending limits that were imposed, okay? So this is the kind of cool thing about agent spending, is you can literally just give an agent a private key, allow it to transact, but at the same time, with something like ampersand, is you can kind of control those guardrails. And again, this was all LLM queries. So this is like a perfect solution for something like OpenClaw, or something where you want to give it access to do a bunch of stuff, but you don't want it to go out and give you $100 bill at the end of the day, right? With your LLM. Okay, so we got about 15 minutes. What I want to do is show one other real world use case. That's a very like kind of a technical use case of like what the architecture of x402 transactions should look like. But more specifically, how else can we use this in a real world scenario? So I mentioned earlier that I'm also the creator of Spritz, co-founder of Spritz. And really what we have here is it's just a chat application, but it has some interesting features that we might want to monetize with x402, okay? One of the first things is, let's say I want to let someone communicate with me and create a call. I want to be able to sell my time, through the platform. So if I come over here to settings, I have kind of all my little settings here. But more specifically down here, I have this calendar, right? So I've hooked up my Google Calendar to Spritz, and it has access to my full calendar. It's very similar to Calendly, if anyone's heard of Calendly. And I also have these availability windows. So I have like Monday through Friday from 9 a.m. to 5 p.m. Central Time. I'm in Texas, and they're all active, and the windows are all working. Then I have this chat enabled scheduling chat functionality. And what I can do is I can have my own custom URL here. And I can say, cool, let's meet. I like building applications on Ethereum. And I can do a free consultation, whatever. This is just for me to give to my friends or like people I'm co-working with or whatever. But then I can also have a paid session, right? So I can say, well, I'll actually meet with you for 120 minutes, and it costs, I don't know, 50 USDC, right? And I can choose what network that I want to receive my payments on. We'll use base, and then I can choose my address. So this is the address I'm connected with, so it's already there, and I can save. So this is a perfect example that like maybe I at some point want to allow people to just schedule time with me. This would be, they would try to call the API, and when they tried to access it, it would say, well, it's fine, but you need to pay. So let's just try it and see. Obviously, I'm not going to pay $50 to myself, but let's just see what it looks like. So here we have like, let's meet with Grixel. I have the free, and then I have the paid. And I haven't tested this in a little bit, but because it's kind of a beta feature, but let's see. So let's say I wanted to do a call for, I'm gonna have to go to the next week because I'll be in, yeah, let's do the 26th. So we click that. It's gonna cost $50 USDC, and I can schedule a call at 9 right here. Say like, what do you want to do? Well, Kevin at edgeandmary.com. Talk about scripts, and then hit this button. So I don't have enough balance, so you can see it failed. But if I had my wallet connected, which I do, and I had a balance, then I could pay this $50 over x402, and then it would. So this is a x402 in the middle of the proxy that's just saying, well, in order to make this final pay, like acknowledgement, you need to pay. So that's one use case that we have in Spritz. Another use case that we have is our agents. So inside of Spritz right now, this is also a beta feature, but you can create an agent that has access to specific tools. And so here's an example. Like, let's say we wanted to create an agent and we wanted to call it subgraph expert, something like that. We could give it a personality. We could make it a public agent that people can find. We'll call it the graph, and we'll give it some tags, blockchain, data. I don't know. Let's give it a few tags and then create it. And then I can take this agent, and where's it at? Oh my God, did it create it? Yeah, here it is, subgraph expert. And I can give it access to special information, right? So let's give it access to graph node, which is a markdown, a Git repo. And let's also give it access to the graph.com/docs. And we can ingest these kind of like endpoints, right? So we're like building an AI agent inside of Spritz and indexing these into its knowledge base, right? And then we can also monetize it. So let's say that I want to, we support adding MCP servers as well. So if you have like a subgraph MCP server configured, you can add it here. If you have an API configured that you want to have access to, like maybe you want to give it a certain API URL, you can add it. And then you can enable or disable web search, whether it has access to its knowledge base. But more specifically on the bottom here, we can give it x402 API access. So you could set up an agent all using no code, give it MCP servers, API servers, access to whatever its knowledge has, and then you can monetize it here. So we have this a way to do a global payment or pay per tool. So you could say like, all right, well, I'm going to charge a penny every time someone calls this agent. Over right now, we only support USDC. And you can see where you want to accept the payments. And so now, if I save this agent is configured, and it's right here, and we have integrations to show how to test it. So if we were to try to do it now, let's try to curl it. Let's see, there's a example code. Here we go. Let's see what it does. So here we have this example curl to query it. Let's come over here. Let's try it out. It's going to say, well, that's great. You can get access to that data, but it's going to cost you 1 penny payment required. So it failed. All right. So this is another use case. If you're building agents that have access to data or have access to something, then you can enable x402 for those agents. Okay, cool. I will stop there. And I think this is a good time to stop and answer questions that people might have.
Thanks, Kevin, for all the demonstration. For the moment, no question, but don't hesitate. Like maybe I have one just about the name. Like maybe because it's not like sexy at all. Say x402. Like if you have to rename this protocol, like do you have any name in mind?
Oh, because they're saying
Or
x402 is like,
simplify.
oh yeah, x402 is a little bit hard to say. It's a little chunky. I guess it's very developer friendly. I don't know, man. That's a tough one because yeah, there's so many like existing payment protocols that are like Web 2-ish, like Stripe. What are these other ones? Yeah, I don't know. I don't know what I would call it. I'd probably call it Zap. I think Zap's a cool one. I was actually gonna create a wallet called Zap. I think Zap
Okay.
would be very like catchy. Zap.
All right, all right. Yeah, so as I mentioned at the beginning, like there is some projects right now that are integrating x402. Like I know an hackathon has been run recently by Ethereum Foundation, and Kevin, you were mentored there. Like, do you have any kind of projects in mind that is coming up through this hackathon? Um, I remember one, but not in this hackathon. Like probably I will just talk about it because it's related to students. So basically, it was an agent that was there just to negotiate prices, like to access resources. So when you were student, it was cheaper to access resources than if you are like a user, a classic user already rich, let's say. So this kind of things like this that can be great. I remember it was like just an agent. You were asking, okay, I want to get access to these resources. It was like a report about, I don't remember which one, but it was a paid one. And so the fact that they were students, it was something that including ZK behind it, but I mean they were able to understand that people behind was student, and so just providing a real discount, just because they were students. So there's like a lot of use cases, to be honest, into x402. So yeah, I feel that it's something that we will explore a lot during the upcoming months anyway. And yeah, maybe could you go through the starter kit, like which starter kit we can use basically to build the agent, especially um, maybe I remember Nader with doing like has built something. Yes, yes, this one as well. But Nader built something like a starter kit. And yeah, I
Mhm.
remember Skyfall has also like an extension about it. Yeah, maybe go through it.
Yeah, I don't know. So okay, so I know of a couple. So if you want to get started like quickly and easily and you don't really know much about Ethereum, there's this x402 that was created by Carlos at the Build Guild, I believe. that is an extension. So you can basically do, a scaffold heap installation, and you just do dash E at the end and then x402. So that's one. There's also Agent Zero, which is specifically focused on ERC. Is it this one? I think it's this one, Agent Zero. Oh, I don't know if that's not the right one. Agent Zero, ERC 8004. I don't know the URL. So this is Marco de Rossi's project. It's basically an SDK that gives you access to, here it is, ag0.xyz, which gets you access to building agents that are ERC 8004 enabled. I guess the benefit here is that he is one of the core contributors on ERC 8004. So if you're building an agent with Agent Zero, you can kind of guarantee that it's going to be able to handle all of the functions to do registration and work with the protocol well. We're probably going to add a way to make it easy to work with Agent Zero with the ampersand SDK. That's another one. Obviously, I talked about that earlier. If you go to EdgeNode's GitHub, there's ampersand.sdk. I'm trying to remember what Natter's AI starter kit is. You remember what it's called?
X402 starter kit, I guess.
Oh yeah, so I think his name is Natter x402.
Oh, on GitHub, yeah. It was on GitHub.
Yeah, I think his name is Natter on GitHub. Yeah. Oh, here it is.
Yeah.
Dabbit3. I always forget what his GitHub was. Yeah, so I haven't used this one, so I can't really speak too much to it. Let's see. It looks like it's been around for a little while, but it hasn't had updates in a while. So I love Natter, but I think he's a really busy guy. And so I just don't know if this one's, up to date. But I think it's a good starting point to toy around with, you know what I mean?
And I remember one just released like 1 or 2 days ago. I mean, it's a good resource to go through. It's like agentic wallets from CDP. Yeah, they just released that agentic wallets.
On Coinbase developer platform. Oh yeah. So yeah, they're
Yeah.
doing something. They're actually doing something similar to what we're already doing at Ampersand, but yeah, they're trying to do like hosted wallets. I mean, technically, you don't need something like this to build agents. You can just use like basically embedded wallets with Coinbase. So you can basically like hook up their CDP stuff, and you can just do your own embedded wallets. I think this is a little bit different. Let's see here. So this one has standalone wallet. Okay, so I guess this one can call MCP tools. Yeah, this one's specific to base.
Yeah.
So I think so I think there's definitely some things where it's interesting, but yeah, I don't know. I don't think you want to build something that might just only be for base. Yeah, I don't know. I need to look at it a little bit more. I know it just came out like this week, so.
There is a couple of questions on the chat, so maybe if you want to go through it.
Yeah, for sure, absolutely. Right, let's see here. Is the agent identity tied to Google layer, or could it work with decentralized IDs too? So I think in like a Google A2A architecture, this is just for like if you're running agents inside of your own infrastructure, how they kind of like find each other. I think that you would basically add any kind of like additional identity. Like there's no reason that Google A2A agents can't also be registered with ERC 8004, and that is the mechanism for finding each other. It's just think of the agent cards as just how they kind of find each other, right? And the Google A2A is just a way for them to like orchestrate each other and find each other. Can we use Spritz for normal actions like tool type Calendly? Can do agents, video calls. Yeah, so right now, like Spritz is can hook up to any MCP server, pretty much any API. It has access to your calendar. So one of the things you can do is you can have like an AI agent that you can send to anybody and just be like, hey, you can talk to my assistant and he'll schedule time with you. And you can literally say, hey, like schedule a meeting for me. And it will be like, sure. And it will fetch the calendar and do all that stuff. And so that's very, very useful. There's also access to like events databases in there, and you can work with Spritz to like create custom agents. So if anyone needs a custom agent, let me know for like events or whatever. Yeah, there's a good, so also for the Spritz stuff, if you go to docs.spritz.chat, I'll put it in here just so you have it. That has all the specifics of like what you can do with the agents. Let's see. I think that's all the questions, yeah? Yeah, it was basically, yeah, I think we got all the questions answered.
All right, all right, all right. So thanks a lot for the session, and sorry at the beginning. So
Oh, no worries.
so on the live stream we skipped the explanation of x402, but that's all good. Like everything will be on YouTube anyway. All right.
Yeah, and I was gonna say if anyone has not, check out Spritz. Go to app.spritz.chat, and there I created an x402 channel for us to talk in. So come in there and let's talk about x402. It's my last initial.
All right, all right. So just to let you know for everyone, so the next session will be with Vito from Ethereum Foundation about ERC 8004. So yes, still some weird name for everyone who is entering into the space is like horrible anyway. Um, but yeah, we will talk more about agent reputation. So next time. All good? All right. Thanks a lot, everyone.
Hard starts.
Tschüss. Bye.
Starts.